Alright, this is going to be a fairly short lesson on the chain rule, and it does deal with composition of functions, or function composition, sorry about that. So really this is kind of the way you're going to see it. You're going to see f of x, and you're going to see this big old thing, and notice that this power is outside of another rather elaborate function. So that's what we mean by a function composition. There's one function inside of another one. So really what I could do is I could call u this stuff on the inside, which is x cubed minus 3x squared plus 7x minus 2. And then this expression could be rewritten as f of u equals u to the fourth. And so what's inside the function, what's inside this u, is this other elaborate function. And so u is the inside function. You probably saw this more frequently in terms of f of g of x, or f of g of x. And this did not mean you multiply these two things. This meant x was a function, a composition of functions where g was inside of f, g is inside of f. So I could have called this g of x, and that could have been a g of x, and that would have been in there. But I'm going to use this u and f notation because it's a little bit easier to do the chain rule. So if you have a function composition or a composition of functions and you want to find the derivative, so if I want to find the derivative of this function, the derivative of that, so what I'm going to do is I'm just going to quickly, just for notation's sake, change this to y equals f of u. And these are both separate functions. So if I want the derivative of y, so if I want to know what y prime is, or dy, dx, whatever, I have to take the derivative of this function on the outside. Whatever the derivative of the function on the outside is, whatever rule applies to the outside function, I apply that rule, and I leave the inside all by itself. So whatever's on the inside of that just sits inside of the derivative rule for that outer function. Then I have to multiply that by the derivative of whatever the function is on the inside. So I have two derivatives happening. I have a derivative of whatever the outside function is. In this case, that's a power of 4, a power rule. And I have a derivative of the inside function, and the inside function is this polynomial. So I'm going to apply the polynomial rule. So if I want to find the derivative of this actual function, in this case, it's going to be the derivative of the outside function. This is my outside function. That's outside of all of this. And the rule for that is the 4 drops in front. I'm going to write it underneath here. The 4 drops in front. Whatever's in the parentheses stays in the parentheses, because that's not part of the rule. The rule just reduces that by 1. That is the rule for f prime, the outside function. So inside of that still lives this entire expression. I didn't change that. My u value is still in there. U is equal to this whole expression. So inside this is still x cubed minus 3x squared plus 7x minus 2. That's all living inside of that first piece. Now I'm going to multiply that by, and this little dot does just mean multiply, the derivative of u. Well, u is right here. That's a derivative we can find. So if you have to do this in separate pieces, you could identify u and then underneath it write what u prime is. In this case, I know what the derivative of that is because I gave a pretty easy polynomial, times 3x squared minus 6x plus 7. And that's my derivative. Now, sometimes you can simplify that. In this case, I cannot, because I am not going to cube this. It's not a binomial, and I'm not going to multiply all that out. So that is your chain rule. And good luck. See how they go.